Let's take a look at how we might graph a rational function. So let's take a look at how to graph this rational function, and I'll try to go through it slowly, but I tend to try to go quickly because otherwise I'd have like a 30-minute video. First thing I'm going to do though every time is to factor. So numerator, numbers that multiply to -6 that have a difference of -1 would be -3, +2. Denominator, numbers that multiply to 6 with a difference of -5 is -6, +1. Notice nothing cancels, so I don't have any holes in the graph, but I will have some asymptotes. To find intercepts, the x-intercept is found by setting y equal to 0. So essentially what I have is 0 equal x minus 3, x plus 2 over x minus 6, x plus 1. Now keep in mind, when I solve this, my very first step would be to multiply each side by x minus 6, x plus 1. X minus 6, x plus 1. Now on the left side, I can see that I'm still going to have 0 because anything times 0 is 0. And on the right side, things cancel. So what I'm basically saying is I only care about the numerator when I'm solving. The denominator only tells me where to restrict my domain. So I have 0 equals x minus 3 times x plus 2. If I set x minus 3 equal to 0, I get x equals 3. Remember, that is the point 3, 0. It's not the line x equals 3, it's the point. X plus 2 equals 0 gives me x equals -2. Again, that's a point. And I'm just specifying because when we write asymptotes, we write them as x equals, and it's actually an equation. So 3, 0 would be here because my scale is 2, and -2, 0. My other intercept would be if I set x equal to 0. So I'm just going to not show a ton of work. 0 minus 3 is -3. 0 plus 2 is 2. 0 minus 6 is -6. 0 plus 1 is 1. That gives me -6 over -6, or 1. So there's my y-intercept, y equals 1. So now let's look at asymptotes. Asymptotes occur when I have, for a horizontal asymptote, let's go with blue. So let's start with horizontal or slant. Means I'm comparing numerator and denominator. And so in this case, because they're the same, I'm essentially just reducing x squared over x squared, which of course is 1. So I have a horizontal at y equals 1, which looks like this. And then my vertical, let's find a different color. Vertical, let's use red. My vertical asymptotes occur when my denominator is undefined. So if x minus 6 is equal to 0, I get x equals 6. Again, this is actually a line, x equals 6, which looks like this. And then I have x plus 1 equals 0, which means x equals -1 is a line right here. Now keep in mind I've got a domain here, and typically I'm not going to ask you to write the domain, but I might in a different question ask you to just find the domain of a rational. Keep in mind the domain is only restricted by these guys where my denominator is 0, or if something canceled, that would also be a part of it. So basically my domain is everything except those values. So -infinity up to -1, union -1 up to 6, union 6 up to infinity. So I just threw that in there as a gentle reminder that our domain includes everything except where our denominator is undefined. Lastly, I really just want to graph this thing and get it over with, right? So what I'm trying to do is look at my first, say, column. I'm either going to have a graph at the top of the blue line or the bottom of the blue line. because it's on the outside. So on the inside it's going to be a little bit different. But on the outside I've got to graph one or the other. So I can see that because I've got an asymptote here at y equals 1, and I have an asymptote at x equals -1, I'm going to have a graph on this region that looks like this. Now, how did I know that without plugging in any points? Because I already knew this guy existed at -2, which we had found previously, and that means I knew it had to be in that lower left region. So similarly, let's look at the right-hand side. We'll get back to the middle in a second because that's the hardest part. But on the right-hand side, I either have to have something up here or down here because I can't cross this blue line. This guy can't be crossed on the outside of the function. It can be crossed in the middle, which we'll see in a second, but I can't cross it on the outside. And since there's no intercept here, as we can see from our work previously, that means my graph has to be up here, and I'm just going to follow my asymptotes up here. So those two parts of my graph are the easiest. The not as easy part comes here in this middle section. So I know two of the points, and so I essentially know this is happening down to here, and it's crossing over to here. And now my question is it going to now turn around and come back and go back up, or is it going to go down? So this is where finding another point might come in handy. So let's find a point at, say, 5, f of 5. Let's plug in 5 using that same strategy I used before. 5 minus 3, positive 2. Get your signs right. 5 plus 2, 7. 5 minus 6, -1. 5 plus 1 is 6. I get 14 over -6, which is -7/3. -7/3 is, if I go to 5, -7/3 is down here somewhere-ish. So that really answered the rest of my question, is this guy is now going to come down and continue to follow that asymptote. So this is what that graph of the rational function would look like. So here's another function for you to graph. I would like you to try it on your own first. If you get stuck, don't worry, it happens to everybody. Go ahead and press pause, try this question, then press play to see how you did. This one is a tiny little bit tricky because of that negative guy on the bottom. So what I want you to do is I want you to think about putting that negative out front, because really I'm going to take a -1 out of this and get x plus 3. So I'm going to put the negative out front and then put the x plus 3 on the bottom. On the top, I'm going to take a 2 out of everything, which gives me x squared plus 4x plus 8. And that can be further factored because numbers that multiply to 8 that add to 4, I'm sorry, this should be 4. That can be further factored because numbers that multiply to 4 that add to 4 are 2 and 2. So this is a 2 on the outside, and then x plus 2, x plus 2. So that's my factorization. This negative is going to maybe trip us up a little bit, so that's why I chose this question for us to do together, so that you had an idea of what like a really hard question might look like. But let's start with intercepts. So I'm going to start with my x-intercept, which means I'm plugging in 0 for y. Keep in mind that I really only care about my numerator. We talked about that in our last example. So I'm going to say 0 equals 2 times the quantity of x plus 2 quantity squared. Divide each side by 2. Take the square root of each side. There's no plus or minus on a 0. And then subtract 2. So -2 equals x is an intercept. Remember, that's the point at -2. So that's not an asymptote. This is the point, -2, 0. My other intercept is the x-intercept, the y-intercept, which happens when I take 0 and plug it in for x. So 2 times 0 plus 2 quantity squared over, keep the negative out front, and then 0 plus 3. So what happens? I got my negative out front, 2 times 2 squared on the top, that's 8. 0 plus 3 is 3. So negative 8/3 on the y, real close to negative 3, but not quite. So that's where I am so far. Again, keep in mind that's up the point, negative 8/3 comma 0. Now let's look at asymptotes. Asymptotes, horizontal asymptote occurs when I compare these values. So if I were to compare, the numerator versus the denominator, I end up with a degree that's greater on top, which gives me a slant asymptote. And this is where we have to be super careful. Because I chose to move this negative out front, what I'm going to be thinking about this function as is negative 2x squared minus 8x plus 8, because I really want the negative, minus 8. I want the negative to be reflected in my question. I can't just totally ignore it when I do synthetic division. So I'm taking this divided by x plus 3 is essentially what I'm going to do using synthetic division to find my slant asymptote. So that means I'm going to take negative 3. I'm going to use negative 2, negative 8, negative 8. Bring down the negative 2, multiply it, add it, multiply it, add it. Remember, I don't care about a remainder when I'm finding a slant asymptote. I'm looking at what's left over, so that's my function. 1 less than x squared, so y equals negative 2x minus 2. So if I didn't include that negative in there, I would have ended up with a slant asymptote going the wrong way, which is what I did the first time, and then I just, face palmed. So from here, I'm going to go to negative 2, which is about right here. I'm going to use my slope of negative 2 that says down 2 to the right 1, or up 2 to the left 1. Oops, my other guy disappeared. Down 2 to the right 1. So, this is our slant asymptote. Now let's see if I have a vertical asymptote. I bet I do. Let's use green. I haven't used green yet. So vertical asymptotes occur when my denominator is undefined. So y equals, I'm getting crazy. X plus 3 equals 0. Subtract 3, x is negative 3. That's this line right here. So this one's kind of a fun little guy to graph. First, let's look at the domain, because I always tend to forget that. The domain, remember, is everywhere except the denominator is undefined. So the only time it was undefined was at negative 3, which we found out in this asymptote. So my domain is from negative infinity to negative 3, union negative 3 to infinity. Now, let's go back to graphing. Let's get to the fun part. In everywhere to the right of negative 3 on my x, I can see that I have a point at that purple point that occurs in this region. So I know my graph, that was a poor excuse for a yellow line, my graph's going to look kind of like this, because I'm not going to cross over that asymptote. So I had to go through that purple point, but now to the left of negative 3, I don't know if I'm graphing something here or graphing something here. So what's the best way to find out? Use a test point. I'm going to use negative 4. So f of negative 4 would be 2 times negative 4 plus 2, quantity squared, over negative 4 plus 3, which gives me 2 times, that would be negative 2 squared, which is 4. Negative 4 plus 3 is negative 1, so I end up with 8 over negative 1. I think I messed up a negative somewhere. Oh, there's a negative out front. See, you gotta be careful with those guys. So I end up with negative 8, which is really just positive 8. So I have the point negative 4, comma 8. So that's negative 4, comma, this is 3, 6, 9, negative 4, 8 would be about right here. And so that tells me the quadrant in which my little guy is graphed. So it's going to look something like this.